Right, we learned in a couple of classes that OSPF depends on the link state advertisement. It is the link state advertisement that makes the link state database, on top of which the spanning tree protocol, sorry, not spanning tree, shortest path first protocol finds the best path. So the basic building block is LSA, link state advertisement, LSA. Now this LSA is of various types. Why do we need to have various type of LSAs? If you see newspaper, we have local newspaper, we have national newspaper, we have international newspaper. Why do we have that one? So that when you are sending a newspaper to another state, you will not put all those local messages, because no one will be interested in reading local message of this state in another state. So we will according to the circulation, according to where it is being given, we define the content in the newspaper, isn't it? So because you got different newspaper, different like local, national, international, because you got different types, local, national, and international, because you got different type of newspaper. Those paper types can help you to filter. For example, I'm a newspaper company. I work in India magazine. Now, if I have a magazine in India, when I circulate the paper to within India, I'll have more information about the Indian local government, state government, the policies, everything in detail. But same newspaper company, when I put some newspaper in the airlines where the international passengers are coming, for them, I will not give the same newspaper, because they are not interested in knowing about the weather report of Chennai or Thiruvananthapuram. They're not interested in that. They want international news. So the same newspaper company of mine, when I am delivering the newspaper to the airport people, international airport, when I'm going to keep some newspaper for selling or for as a complimentary, when I distribute in the airlines, I keep only the international standard news. So I filter all the local news, isn't it? Because you have a news called local news, another category called national news, another category called international news. You are able to tell the employees, hey, filter all the local and national news. Only put the international news. You can easily tell them what to filter, isn't it? Because you got three type of news: local news, national news, international news. When you tell to your employee, you easily tell them, filter all the local news. Then they understand that they should not talk about the weather report in Thiruvananthapuram. Right. So because the news is classified as local, national, and international, you can easily do that. You can easily filter what you want to filter. Likewise, if we have many areas, like many countries and continents, we have many areas in OSPF autonomous system. Now, when we have different type of advertisements, one advertisement is only focusing on local network within an area. Some advertisements are going from one area to another area. When we are focusing on advertisements, when we have multiple categories of advertisement, you will easily match those local LSAs, link state advertisement, and filter them before sending into another area, because the other area is not interested much about your local network. So we need more than one type of link state advertisement. We want to classify LSA types. Yes, we have 9 different type of LSAs. Sometimes you can also say we have 11 different type of LSA if you are working on IPv6, segment routing, etc. But in general, you can say 9 LSA types. We are going to see in detail.
Yeah, got it.
Let's see. Configuring LSA state, link state advertisement. Now you see, if you don't have many areas, when all are in single area, when you don't have many areas, when all when all the routers are in single area, what is the problem? The problem will be the routing table will be too big, and the SPF algorithm will be keep on running because every now and then there will be some network going down, coming up, isn't it? When the routing table is too big, then advertisement will also be too much coming because there are too many networks. If all the networks are in single area, too many LSAs you need to get. If you get too many LSAs, then too many times the SPF algorithm will be keep on running, and the routing table will also be too big. Time taken to process will be more. The memory consumed will be more. So to avoid all this, only we go with multiple areas.
Yeah.
We got many areas. Area 1 has got a boundary. Area 2 has got its own boundary. Area 0 has got its own boundary. Because you got multiple areas, with the help of LSA types, you can minimize the routing table update. You can say, hey, these are all local LSAs. Don't send to others. You understand? Same like, you have many countries. If there is no many countries and continents, if the entire world is one big nation, it will be very difficult to manage. You cannot even imagine, You cannot even imagine one big world controlled by one organization. Not possible. That's why we have continents, countries, states, union territories, etc. Easy to manage, easy to solve the problems. So we have big autonomous system inside which we got multiple areas, consist of areas. Advantage is minimizing the routing table update. We can reduce the size of the routing table by localizing the advertisement. All the area 1 networks, you advertise only within area 1. Then how will area 2 ping area 1 network? You will send only the summary of it. No need to send detailed. Yeah, because area 2 will not be often talking to area 1 member. If they are often talking, then you would have put them in area 1 only. You will not put them in area 2. Why did you put them in different area? Because they don't talk often. Area 1 members, they all talk each other. Area 2 members, they all talk each other. So you put them in different groups. So you do not want area 2 to simply advertise all the update to area 1 because area 1 is not interested much about area 2 networks. That's why they are in different area. So when we have different LSA types, link state advertisement types, you will be able to easily filter by summarizing. See, that is the next. If you got many networks in this area, if you got many networks in this area, that network will be advertised to all the routers here, but when you advertise to the other area, you advertise only the summary of it. What is the advantage? The bandwidth will not be consumed much because you are sending only the summary. Second thing is the CPU utilization will be less here. If you send too many, then it needs to process too many updates. If you send the summary, the time taken to process, the process utilization, everything will be less. Isn't it? So we need different type of advertisement so that I can tell to this router, hey, local advertisement don't give to other area. Don't give. Okay, so this is unwanted topic coming in the middle. Let's jump for a while and go to the actual topic. Here, we are talking about LSA types. So let's continue that. You see, there is an LSA called
Yeah.
router LSA. As the word says, router, this particular type 1 advertisement is generated and advertised by every single router. This advertisement is advertised by every single router. But this advertisement will not go to other area. This advertisement, if the router belongs to area 1, the advertisement coming from that router will only go to area 1 members. It won't go to area 0. It is local. Type 1 LSA is local to area. Local within area.
LSA type.
Second is LSA type 2 is called as network LSA. This network LSA comes from designated routers only. And this LSA is also local within area. You understand? So this both LSAs, they will never go to other area. See, every router advertises the link state information. That is called router LSA. And only the DR advertises the network information, that is called network LSA. But both these LSAs are local within an area. If both the LSAs are local within an area, if both these LSAs are not going to go to other area, then how will other area know about this area? It is with the help of type 3. You see, where do you do summarization? On ABR, isn't it? ABR is the place where we do summarization. But by default, OSPF will not do summarization. By default, OSPF will not do summarization because this LSA originates from the summarization point. The name is given as summary LSA. For example, if you see this picture, let's say this is DR. Let's say this is designated router. This will send type 2 LSA as well as type 1. And this will send type 1. This will send type 1. This will send type 1. Now, this LSA will even go here, type 1. Because this is also in area 0, area 1 only, type 1. Now, this type 1 will be only within the area. It will be circulated only within the area. Type 2 also will be circulated only within the area. So, these network information never goes outside. Outsiders will never know about this network. Let's say 1.1.1.1. This router will never learn about 1.1.1.1 with the help of type 1 or type 2. Yeah? Type 1 or type 2 is not going to advertise any network to outsiders. But this router knows about all type 1 and type 2 of this area, isn't it? Why? This is a member of area 1, isn't it? So this has got the privilege of talking to area 0 because it's an ABR. So this is the place where all the type 1 and type 2 are converted as type 3 and sent. So it is going as what? Type 3. So what you need to do is, when you do summarization, the summary of type 3 is going. For example, 1.1.1.1, 1.1.1.2, 1.1.1.3, 1.1.1.4. Let's say like that you have 100 network, 1.1.1.100. So type 1 and type 2 is advertising 100 route information, isn't it? But type 3 will just simply say 1.1.1.2, 1.1.0/24. Just only one update for 100 inside network. Type 3, if you summarize, again, I'm telling you, only when you do summarization, the type 3 will be summarized. If not,
correct.
The type 3 is going to be also detailed only. You understood?
Mm-hmm.
No. ABR will not summarize by default. If you want to do summarization, this is the place you can do summarization. That is why the LSA that goes out from here is named as summary LSA, but in reality it is not summary LSA. In reality it is going to be detail only. But the name is given as what? Summary LSA. You are not getting. It is going to advertise a detailed LSA, but name will be summary LSA. But why they named it as summary LSA? As a good practice, we usually do what? Summarization here. We will do it manually. When you do manually, it is going to be summary LSA. Let me take you there and you can read for yourself. You see, by default, see the last line, read the last line, please. By default, routes are not summarized. Type 3 LSA is advertised for every single subnet by default. They are not summarized. But what is the name?
ABR is going to summarize.
Name is summary,
if it is not
but by
summarized,
default they won't do summarization. Then why they have named it as summary LSA? Because as a good practice, we always do summarization manually. So you see, the type 1 is now converted as type 3. So other areas will never learn our area network as type 1 or type 2. They will learn as type 3.
Okay.
Because you got different types, when you do summarization, only here it will be summary. Here it will not be summarized. It will be detailed in this side. Because in this side, they don't focus on type 3. They focus on type 1 and type 2 for local, isn't it?
Summary LSA, okay.
So let me also take you to this type 1. You see, type 1 LSA. It is coming from every router. And it is flooded within the area only. It does not cross ABR. What is going inside is the router ID of every router and all the networks of every router. Now, type 2 LSA is also flooded within the area. You see the last line? Is also flooded within the area and does not cross ABR. All right. So advertised by the DR of the broadcast network. One network, type 2 LSA for each transit broadcast. Forget about NBMN. So what I'm trying to say is this is originating only from DR. Type 2 LSA is called as network LSA. And this is also within the area. It will not cross the boundary. Yeah? Does not cross the boundary. Did you understand 3 types? Now, type 4, I want you to just give a reading. And also I'll show you type 5 after you finish this. If you say you finish this, I'll show you type 5 page. You read both and then I'll explain you. Now, you can take your time. Let me know once you are done this. So I'll first explain type 5, then I will go to type 4. You see, in an area, you may have an ASBR. In an area, you may have an ASBR. See, ABR will be there in between area 0 and non-area zeros. But what is ASBR? ASBR is the place where you have some other source like OSPF or some other protocol. It may be another OSPF or it may be EIGRP or RAPE, something like that. And this side is OSPF. So you do what? Redistribution, isn't it? This is what we call it as ASBR. Those external network are identified as type 5 LSA. Now this advertisement, when you redistribute, it originates from the place where you redistribute. It originates from the ASBR itself, isn't it? From where it is originating? From the place where you redistribute.
Yes, I understood.
Yeah. So it is advertised from the same place where it is it is originating. Now, by default, this also won't summarize it, and it is flooded throughout the autonomous system. Meaning, it starts from here, it goes to all the routers in area 1, and it goes to all the routers in area 5, area 0, and it goes to all the routers in area 2. What I'm trying to say is, because it is going to all the areas in all the routers, you must do what? Summarization. Right? Otherwise, the entire internet will try to get inside your office routers, and the office routers won't have the capacity to handle that many thousands of routes. So we do summarization on ASBR. Now, what is type 4 then? Type 4 is coming from here.
Yeah.
Why?
Correct.
Because in this area 1, this is the representative of area 1 to other areas. So this router will say, I got a person called ASBR. For example, if the router ID of this one is 7.7.7.7, ABR 1 will say, I have an ASBR. His router ID is 777.
Yes.
Please understand, type 5 is external networks like Yahoo, Google, Facebook. That is type 5. But type 4 is not Yahoo, Facebook, Google. Type 4 is the router ID of the router, which is responsible of bringing inside Yahoo, Google, and Facebook. You got it? That is what we see here. You see this ASBR. This ASBR information is coming as type 1 up to here. And then it is converted as type 4 and sent to other areas. Type 4 is just a router ID of ASBR. Border router. It is running both OSPF and the other autonomous system protocol. OSPF and other autonomous system protocol. That is simply to say, type 1 simply to say,
correct.
This is the link status. Type 1 is what? Router LSA, no? This is the link status, but this router is also bringing external network. That information is what makes it to be converted into type 4 instead of type 3. Only router ID. Only router ID of the router. So every router will know that this is the router ID who is responsible for external network. And, network information of outsiders. Type 4 is not bringing the network information. Type 4 is simply bringing the router ID. Yeah, it's like it is like Mr. Anand is responsible for all the transport. That's all. So if anyone wants to go talk to transport desk, they will reach Anand. But which route? Route number 1, route number 2, route number 3.
That is nothing but like external autonomous systems router.
That is coming as what? Type 5. Type 5 will say route number 1 buses, route number 2 buses, route number 3, all those information. That is what many people need to know.
So ASBR, it will send type 1
to know where they, according to where they want to go. If they want to go to if they want to go to Kurupambadi, route number 8. That is not going to be given by type 4. That is given by type 5. But if I want to
type 4 is
go to Kurupambadi,
of router ID.
I need to talk to Mr. Anand. That is type 4.
But
until you reach Anand, you will not know route number 8 is Kurupambadi route.
And
so,
type 5 consisting
of
the
type 1, type 2,
information,
type 3, type 4, type 5.
Outside.
Type 1 is router LSA. This LSA originates from every single router within an area. This LSA will not go to other area. Type 2 LSA is called as network LSA. This is also within the area. It won't go to other area. Type 3 and type 4 both originates from ABR. So they got the same name, but they are not same. Type 3 is bringing the network of one area to another area. Whereas type 4 just brings the router ID of the ASBR. Type 5 brings the network of the external. Type 4 originates from the ABR of the area which has got ASBR. Whereas type 5 originates from the redistribution point itself, the place where you redistribute. You got it? Type 6 is only for multicast if you have multicast service with OSPF. Type 7 we'll learn later when we talk about special area types in the next chapter, which is called not so stub area. Type 7 is not so stub area, which is coming in the next chapter. Not so stub area. Type 8 is whenever you have OSPF along with BGP redistribution, when you take BGP routes and give, then those BGP attributes are carried in OSPF as type 8. Type 9, 10, and 11 called opaque LSAs, they are used for various features like IPv6, segment routing, blah, blah, a lot of other things. Okay, so the important LSAs that you should know by with clarity is that first 5.
Got it.
Because with that only we'll be tuning. The other areas, the other LSAs are automatic. When you use multicasting, it's going to be type 6. When you use not so stub area, then it's going to be type 7. When you have BGP's route distributed through OSPF, then it is type 8. Type 9, 10, 11 opaque. Are you clear with the first 5?
Yes.
All right, sir. We'll stop.
Yeah. Yes. Yeah. Yeah. Mm-hmm. Yeah. Okay. Yes.